Namely, you are familiar with the terms like voltage, ampere, and resistance, impedance. You should be familiar with the direct current, alternating current. Then should be familiar with the sinusoidal voltage, the sinusoidal currents, and their parameters as they operate in the system. Now, these parameters, of course, is being determined when they deal with circuits. So understanding electricity will as well be good to be understood when we deal with circuits. So circuits is a composition, or is a configuration of elements where electricity can pass, where electricity is an important matter on that particular and those particular elements. Now, in the circuits, there are just three types of passive circuits. Okay, this kind of elements that are included in the circuits are either resistors, capacitors, and inductors. Okay, now you know what is a resistor. A resistor is something that resists the flow of electricity, and an inductor is something that induces magnetic field once the electricity passes through a conductor. And capacitor is an element where electricity can be stored temporarily. Capacitor is not same as a battery or the source of an electromotive force. But capacitor is an inactive or passive circuit, passive elements where it can either store and then discharge electricity. So a capacitor is an element in a circuit where it either can store a static electricity and make this static electricity a dynamic one. As you know, in your study of your physics, there are two types of electricity. Did you recall? One is static electricity, and the other is dynamic electricity. The static electricity is by nature, because it's said to be static, meaning to say it's a kind of electricity that is not in motion, or a kind of electricity that is not moving. Example of this electricity is the static charge that your body, that your example, your clothes can accommodate. Another example of this static electricity is the lightning. The phenomenon of the lightning is a form of static electricity. You know, this that becomes static electricity where there is a static electricity in lightning when there is change in the weather conditions, so that the evaporation of water from the earth carries over some ionic charge, and it goes up to the atmosphere, so that there is now a depletion of electrons on the earth's surface, so that the positive charge goes up together with the clouds. So as positive charge goes up together with the clouds, there is a formation of positive charge there. A continuous evaporation of water continuously adds up to the quantity of charge that is accumulated on the atmosphere, so that when this charge becomes so strong, now that the positive and negative charges that is present in the clouds and in the earth respectively will attract each other, and then when there's their attraction so strong, that's the time that lightning will occur, because the barrier that separates this positive and negative charge can no longer hold that force of attraction, that finally the positive and negative charge collides. Now, this time, there is an instant dynamic um, motion of the charges, and that approximates to the speed of sound, the speed of light, the reaction time of that attraction of positive and negative charge. Though uh, it cannot reach the actual speed of light, but it approaches that fast. So the reaction is very fast. That's why when the collision of these charges happen, you see that there is light, there is heat, and there is sound that is being created. So you can now imagine what static charge can do. Maybe you had an experience when you wake up in the morning and you walk towards your towards the door, and then touching the knob. The knob often is made up of metal, and upon touching this metallic knob, doorknob, you experience some tingling effect on your finger, like as if you touch an electrical live wire, that you feel some kind of some kind of electrocution. You feel that you electrocuted. That means that you are carrying with you a static electricity. Okay. Uh, Janelle, are you now in? May I check Janelle Santa Ana? Are you now in? Okay. Okay. So one important component of two very particular thing in electricity is that there is always a conductor and there is always an insulator. You say that an insulator is the opposite of a conductor. So what's the difference between the two? In order for the electricity to be dynamic, there must be the conductor. A conductor is where electricity can possibly pass, and often the conductors are made up of metal. Okay, metal, I can say all metals are conductors. So what makes a difference between the conductors and insulator? Uh, Wait a minute, I'm trying to accommodate Janelle Santa Ana. She cannot join in the meeting. I don't know. I don't understand why she is unable to meet. the same. There are two. There are always two. There are always two parts which will be always dealing with, and these are the conductors and insulators. What's the difference between conductors and insulators? Is that conductors have more free electrons. Insulators, no free electron. Why is this so? Why is this so? Okay, welcome to the class. Pumasok ka na?
Yes, sir.
Okay. Yeah, oh, it's okay. Yeah, that's good.
Thank you.
Okay, okay, okay. By the way, are you following? Are you able to follow me in the Google Jam? Friends, are you able to follow me in the Jam board?
Yes po, sir.
Okay, okay. So, to 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 have a bird's eye view of these two things, we understand that an atom is composed of nucleus, wherein the nucleus there is the positive charge called proton, and around that atom is a negative charge that orbits the atom, you call electron. So this electron surrounds the atom, it orbits the atom, so that if the atom is in a neutral condition, the number of proton present in the nucleus has the same number of electron that orbits around that nucleus. Okay, so for example, your hydrogen, there's one, there are two protons, so there will be two electrons around. So that's going to be surrounding around the. Now, if you remove, if for example, if there are three electrons here, there must also be three protons, three positive protons in the atom, so that the attraction of the charges present in the atom will be equal. So if we remove one electron, what happens is that there is now no excess electrons. So all the two electrons will be attracted toward the proton. You understand this very well, that positive and negative attracts. Okay, di ba? It attracts. There is a force of attraction between the positive and negative charge. So if this is a positive charge Q, this is a negative charge Q, the force of attraction between this is given by the value of mu times Q1, Q1, Q2 over the distance of separation R squared. Okay, so that's the force of attraction. You could imagine now how strong will be the attraction between the charges when they are defined. The charge is defined in the unit of Coulomb, And the force is in the unit of course, Newton. Okay, so you just can simply think how strong will be the bond of the atom where in it there are protons and then there are electrons. Okay, so as I've said, a conductor is having more free electron. So we can imagine that an atom with uh, having more electrons, let's say this one has 3 electrons and the proton has only 2 electrons. So we can say that this kind of atom is a conductor. Why is it? Why is it so? Because we know that if this is your atom and then there is an excess electron from outside, okay, so this is now, let's say this is two protons present here and then 2 electrons present here. If these negative electrons get near to the one of the electrons of the proton, of the atom, what happens is that the force of repulsion between the two like charges will cause the atom, the electron to be displaced from one atom to another. Okay? So, kung ining electron na ini, kung ma-displace ini from one atom to the next atom, there is now a movement of charge. So, if there is a so if the electron continually jump from one electron to another electron, there is now a conduction. Okay? So, this happens if you have a conductor, let's say this is a copper wire. It's made up of copper, and you introduce an electron from one end. So there is now this electron will cause the electrons from in the wire to jump from one atom to another until such that it reaches the other end, wherein now the the transport of the charge carried by the atom causes it to be transported from one end to another. That's why if the charge Q travels from one point to another, there is now a rate of flow of charge. Now, you say that the flow of charge per second is called your current, and the unit is in ampere. That's why, now when is this possible? When is this flow possible? This flow is possible because by this, in this case now, there is now a potential difference. Take note, from here unto this end, there is a potential difference. Meaning to say, mas mataas ang potential dito kasi there are more free electrons in this case here at this end than here. So kung dakol ang electron digdi, ining sobrang electron magpo-flow sa baba ang electron sa baba. So because of this, the high potential here, I can say that the high potential here is, let's say it's positive in this case. High potential, not okay, not positive to make it not confusing. So high potential here to low potential here. The difference between the high and low potential is the potential difference. So that this difference causes the charge to be able to dynamically flow. Of course, pag sinabi natin na will flow, that the flow will be like a water that flows from high elevation to the lower elevation. So that is how electricity behaves. Like water, electricity behaves in that way. So if, for example, the conductor now is subjected to a potential difference here, so the high potential difference here, and here low potential difference, because this one is connected to a source of charge. Okay, source of charge, and this is the source. So the charge can flow from high potential to the low potential. Now this is your conductor. So the positive charge can flow now from the source to through and then go back to the source. Now in this case, when we say that the charge is flowing, we can say that there is a current flowing in there. Current I, this is in ampere. And the potential that is present in the source is what you call your, here there is a potential difference where the unit is in volts. Okay. Now, if this is the conductor, you can insert along the way a kind of resistance. Okay. This is your resistance. And often this resistance is the equivalent of your load. So think about now that the source supplies the charge, and the supply of charge is carried over through the conductor down to the load that is represented by the resistor R. Now, by the way, if you have any question as I discuss the topic, please right away ask the question. Do not hesitate. Do not be ashamed to ask question, for as long as that question pertains to the topic I am talking about. So don't hesitate to ask question. Okay, so let me redraw. Here is your battery. There is your positive terminal, and let's say you put some kind of a switch, and this is now your resistor, so that this is the negative, this is your switch, this is your load, this is your, let's say the load is a resistor. So a potential difference present from the source is what you call your E. E is the potential difference, where E is your electromotive force. E is the electromotive force. That is a potential, that is the potential difference at the source. Okay, ang potential difference na nasusukol mo digdi sa load, often you will be able to measure the potential difference by making use of a voltmeter. Okay, so you connect a voltmeter across, you will read the voltmeter in volts. Okay, so what you can see here is in volts. Now, if you close by this time, at this moment, you see that the switch is open. Okay, switch is open. So this static charge in the source of the charge is it cannot move because it will just be present at the terminal of the source. It cannot move because there is no way where it can get make the attraction between the positive negative charge happen to collide. Hindi sila magbabanggaan. Let's say upon closing the switch, that is the time that this charge will suddenly rush. Itong charge na ito will flow in at the rate of coulomb per second, which is your current I. So this having a unit of coulomb per second is equal to the unit of 1 ampere. A unit of 1 coulomb per second is a flow of current of 1 ampere. Pag sinarahan mo dyan, for example, there is a 1 unit of 1 ampere that flows throughout the circuit. That means to say that the source of the charge is able to supply this ampere to be able to be absorbed by the load. Okay, now what happens is upon closing the switch, we consider that there is no voltage drop that occurs at the conductor. So we can say that between the positive potential at the load and negative potential at the load, there exists now a V, where V is your voltage drop. Okay, why voltage drop? Because if the charge flows from negative to positive, from low potential to high potential from the source, okay, and then it goes through the conductor, and then reaching the load, it passes through the load, but this time it starts from high potential as the source and then exit in the load at the lower potential as the source. So this is now the circuit which completes the flow of the charge, where the charge is coming from the source and being used in the load. By the way, when electricity flows, so what happens when electricity flows? Ano nangyari kapag ang electricity nag-flow? Okay? What are the byproducts? Okay? Kung ang electricity mag-flow, kung ang electricity mag-flow, what happens is the potential difference at the source is dropped at the load. Okay? Potential drop at the load at the source is the current. What do you think will be the result? Okay? As the current I passes through the conductor, there is an induced magnetic field, okay, around the conductor. And at the same time, the effect of this, other than the induced magnetic field, through the path of the conductor, there is a production of heat. And if this load is in the form of a motor, what happens is that the motor will produce torque. Iikot, siyempre motor mag-produce ng torque. So, it is always a coexistence. There are always a coexistence of uh, magnetic field, heat, and mechanical work as electricity passes. Okay? If there is no electrical work that is converted by the flow of charge, okay, it's either that the conversion of energy can be from electric energy to a heat energy. Okay? So, electric energy may be converted to either heat energy or mechanical energy or magnetic energy, which a magnetic energy also converts to mechanical energy. Okay? Think about that these three elements that are produced by electricity always coexist. Hindi pwedeng pag nag-flow ang electricity, pag nag-flow ang charge, ay heat lang. Hindi. Palaging may coinciding uh, magnetic energy. It's either if there is no mechanical work produced, at least the heat and the magnetic energy are present. So much so, if a mechanical energy now is the result of this flow of electrical energy, all of this will be present. Okay, so that's how important is the understanding of electrical. Now, as I've said, going back to the as I've said, since the flow is determined by the potential difference, okay, the flow of current is determined by the potential energy, the potential difference that is present at the source of the charge. We can say the Ohm's law suggests that the ratio of the potential energy to the rate of flow of charge is a constant R. So R is constant. It's the resistance that determines how much it is the resistance or this a kind of let me say a kind of parameter that limits the flow of current that will determine how much charge will flow into the circuit through the circuit. Okay, so Ohm's law is being stated by this. Practically, this is your Ohm's law. That means the ratio of the potential difference, the volt to the current, is the value of your resistance. Alam mo ang electrical engineering, all throughout the course, it will always talk with the voltage, current, and the resistance. Sometimes the resistance is called your impedance, because the resistance, it can be either the pure resistor or can be an inductor or a capacitor. Okay, so this is an inductor, this is a capacitor, and this is a resistor. There are different these three elements are practically different. Later we will understand how how this affects the flow of current in the circuit. So this now represents what makes a circuit, what parameters makes a complete electrical circuits. Okay, so let's just for a moment talk only about resistor. Okay, so a resistor can be said to be in several forms that are connected together, but the connection is such that it follows in the same path, so that if this is the potential difference, and when you close the switch, the current will flow through the resistor. So let's say this is R sub 1, resistor 1, this is resistor 2, this is resistor 3, resistor 4, resistor 5. What happens? Whatever current flows in resistor 1 will be the same current, resistor 2, all through the same current that flows from R1 to R2. Okay? So, sabi natin kanina, you can just say that this R1, R2 may just be a single resistor connected present. So this is the total resistor that represents these 5 resistors that are connected in series. So the total resistance can be R1 plus R2 plus R5 and so on. So what do you see here? What current flows through R1 is the same current. So we can say that the current that flows through R1, the current that flows from the source E is equal to current at R1 is current at R2, etc. So R5. We call this kind of circuit to be a series circuit. Series because it follows from one after the other. As the current enters this point in the resistor, it leaves the other end of that resistor, and it enters again the next resistor and leaves, and then so on, and then go back to, okay? So you call this series circuit. Take note that in a series circuit, the current that passes all through the resistors connected therein is the same. All right. Now, it's also possible to establish a circuit that is connected with several resistors. By this time, it is connected in this manner. Okay. So, the potential difference at the source, of course, will be this is the, let's say this is the positive and negative. And when you close the switch, the current I will drain out from the source. But this current I from the source will now divide such that there will be current through R sub 1. So there is current I sub 1, R sub 2, R sub 2. So there is current I sub 2. There is current I sub 3. Okay? Take note here that the total current that is leaving the source will divide among the resistors that are connected in this manner. This is what you call your parallel circuit. Parallel because the current that flows from the source is not the same. It's not always the same as in the resistor 1, resistor 2, resistor 3. Now, take note here in the parallel circuit that if there is no voltage drop in the conductor, the potential difference at the V at resistor 1 is equal to the potential at R sub 2 is equal to potential at R sub 3. Now, as before in the series circuit, we noted that the current in the series circuit is the same. But in the parallel circuit, the voltage is the same in all of the elements. Okay, so that is the difference of the series and parallel circuit. Now, it's also possible that a circuit may compose of both. Okay, so there is a resistor and another sets of resistors such that they are in parallel. Okay, so R1, R2, R3. You note now that R2 and R3 are two R3 in parallel. So R1 is in series. So this one R1 is R1, R2, 3. Let's say, let's call this R2, 3 is now in series. So you actually can represent this, let's say, another drawing na lang. So you actually can represent two circuits into one circuit. Okay. So this is your R1. This is your R1 and R2, R3. No. Okay. So this is now a combination of your R2 and R3. Finally, okay. So finally, you can combine the circuits such that the the resistor will be only one. Okay. So R1, this is now R1, R2, and R3 combined only to R1. So um, if you look at the if you take a look at the configuration of the circuit, it only just reduces to one single component in the load as the current passes all through it and then just go back to the source. Okay, so this is the source, this is the load. Okay, now how do we analyze this circuit? Okay, so let's say a potential difference of 12 volts is at the source and a load of 100 ohms. 100 ohms is connected 100 ohms. This, let's say this is 200 ohms. This is 300 ohms. Okay. Now, how much current will be flowing from the source? How much current will be flowing through 100 ohms? How much current will be flowing through 200 ohms? How much current will be 300 ohms? Okay, if you recall back your physics, can you do an exercise to answer this? What is the total current that passes through all these resistors? Can you do it? It's now 11:13. Maybe in 17 minutes, 11:30. Can you give me the answer? Okay. You just in your sheet of paper, maybe you can do the computation. You can do the computation so that you can send me. You can send me. Maybe you can just send to me in the messenger your answer. Okay, I will wait for 17 minutes to do this. Okay, being the nature of electricity, the elements that is being used in electricity, we will be studying circuits. This is the very fundamental study of circuit analysis in. Okay, I'll go back to you. I'll go back to you after maybe 17, maybe after 15 minutes to evaluate what is your answer. Okay? Uh, so for your sandali maingay. May nagaging basurero kaya maingay.
May patong si Jerry para kaano. Okay mo. Muliyam siya. Kasi kunya. Nabuhan si Alpia kasi siya.
Grabe.
Mag-wari kasi 2 taon na. Si Alpia, hindi ko na papig, pagastusan na namin na. Doon ko yan, bigyan ko yun. At sila, patatunado na kang karir kan. At iwan pa lang na, dala ko siguro.
Yan sana.
May kakong arkilan dito sa may larga, may istasyon mo kang train sa larga. Ito lang. Siyempre, paso doon lang ng pinto na sila. Nag-iray ka, paso doon lang po pa sinana.
Wanita niya.
Tapos may mga pala sa studio. May galing sa sino, kasi ilang kaumang. Mura ko nga rin. Mag-apod na sa kumpata.
Natakot pa lang son.
Hindi ko na ako nasubuan ng doon. Lumayan na. Tidak saya Fortuna.
Jake Robert Dick.
Suatu kali dia jadi ayah kita. May pangalan siya atin na siya atin na ito. Atin siya.
Okay, so this is your circuit. This is 100, 200, 300 ohms. What do you do first? First, in order to be able to solve the currents, okay, we have to resolve the circuit, the first parallel circuit. So the first approach here, current, the total current at 100. What do you do first? If this is 12 volts, the 12 volts will divide between the 100 ohms and the combination of 200 and 300 ohms. So first we determine the actual resistance that will be the result of the 200 and 300 ohms. So let's begin by for the 200, 300 ohm in parallel. What is the equivalent resistance of this? Let's say R 200, 300. This is since they are in parallel. Okay, since they are in parallel, we say that the total resistance for parallel circuit, the total resistance of 200, 300 is equal to 1 over 200 plus 1 over 300, in which this reduces to R3 equals 200 times 300 over 200 plus 300. This results to how many ohms? Okay, so this is the ohms. Now resolve to get the resistance for this is 100. This is the R200, 300. So this is in series. So the series resistance now will be R100, 200, 300 will be equal to 100 plus R200, 300. Now you get the total current now. The total current I will be equal to 12 volts all over this resistance. R100, 200, 300. I mean, do you get what I Do you get my notation here? Do you get the notation here?
Yes, sir.
The subscript of 200, 300 says that that is the combination of 200 and 300 ohms in parallel. And here, the series circuit R100, 200, 300 are the combination of the series resistance. That is a combination of both the parallel resistance 200, 300 plus the 100. So the total current will be the result of the total resistances here. Now, between the parallel circuits, these 200 and 300 ohms, what do? This actually has a division of current. Okay? Take note that the current I will be equal to the current at 200 plus the current at 300. Okay? So what do you solve how do you solve the current at 300?
May portiras po sa diban, may portiras po sa luan. May nagmi sa diban. Nagalot, nagmi sa diban. Gano'n ko sa ganti mo. May nagmi ko sa buhay. Naigin ko sa diaryo. Sa diaryo, nagmi sa diban. Gawin ko sa diaryo, karang katuloy ang katuloy. Chapter ba? Pang, ata ko. Mas magaling pa sa iyo. Abangan kita pa kasi kan marapit mo. Ay, susunod mo sila. Nakuha.
Okay. All right. Okay. For an additional exercise, additionally, what is the voltage drops in its resistors? Okay, so here is another exercise. There are resistors Rx that is in series with the two parallel resistors, 100 ohms and 200 ohms in parallel. Now, what is the value of Rx? So that the total resistance of the combination of the series parallel circuit will be Rx. Okay, can you try this? I want to try this so that next meeting our topic will be Kirchhoff's law and Thevenin's theorem. Actually, the Thevenin's theorem is the same in print. It is this all appears to be similar to that Norton's theorem, except that they have a different approach. But first, we will start to understand the Kirchhoff's law. After we understand Kirchhoff's law, then we'll try to understand Thevenin's theorem. So that will be our reserved topic in the next meeting. Next meeting also, I'm going to give you the complete outline of your course. You know, I tried to change the content of this in such a way that the approach will be, will meet the difficulties that we are encountering here in the, so that our mode of studying the subject will be such that instead that I will be going so much lecture, I'll just be following up on your development, how you able to subscribe on the guidelines, on the, how you subscribe on the topic and absorb what is in there. You know, ngunyan baga, at the tip of the finger, you can just easily punch the topic, enter the keyword on the search bar in your internet, and then thousands and even millions of solution will be available. So you actually will not, there is no reason that you will not get the correct answer to the problem that we are going to solve, because the resources is very much, there is a huge resources where you can refer to. So next topics will be such that it will be you who will present what you've learned about the topic, and what I'm going to do is just to follow whether what you learn is correct or wrong. Okay? Ang tawag niyan, or maybe I would rather divide you into a group. Since there are 29 of you, maybe I'll divide you into 5 or 6 groups, 36, maybe 5 in each group. So I give you topic, and then you discuss the topic. After discussing the topic, you discuss it together with me. You discuss it in the class together with me. And I'm going to follow up whether we are on the right track. Okay? Kasi kung ako magpapara-lecture, siyempre sa oras na na-lecture itong ganito, yung ma-accommodate ko lang sa oras na yun ang may bibigay ko sa inyo. Pero kung kayo mismo ang mag-aaral doon sa topic na ibibigay ko, sooner I'm going to give you the syllabus. Mag-aaral kayo, dagdagan yung inaral, mas marami ang inyong makukuha. Rather than, siyempre, ang limited ang time ko din para ibigyan kayo ng ng lecture. So, ang gusto kong sabihin ay na kung kamo magtatrabangan tanganing makaupod kan sa indong dapat na maupudan, kada saro maghanap ki item, ki idea, ki information na tungkol duman sa pag-adalan nindo. So kung limang klaseng resources ang ma-share nindo. Kasi kung ako lang, alimbawa matao ko, saro sana makukuha nindo sa hali sa kuya. Pero kung involved ka mo, mas dakol ang makukuha mo. You know, skills, there are a lot of techniques, a lot of skills that we can learn. And we can learn more and faster if we learn from others. Because if everything is to be learned by our own, pwede naman ko na, pwede yan. Pwede yan, ikaw mag-aral lang para sa sarili mo. Pero, para mapadali na mas marami ang ating maintindihan, we have to learn, we have to discuss things as a team. Okay? Sa mga ibang countries, yan ang ina-adapt. Tinatawag nila yan ay POGIL, yung process-oriented group inquiry learning. Yan tawag niya. It is a group inquiry. The group inquires with different information and then shares this. So that after sharing the information, everybody knows, everybody learns as the number of individual learning in the group. So mas marami. Kung limang ideas ang available. Kasi kung ako sana, kung professor sana magbibigay sa inyo ng matao sa Indukan, mga duman sana ako makapagkaan. And so, then your information that you generated plus the information that I share will result to a more information that will be beneficent. Okay? So, it looks we have a complete attendance for today. Again, I would remind that those which I called, and those of you who are present, actually I haven't checked all the listings here. If you have a friend who he was not called in the list, I would advise that he or she should check with the registrar in order to be able to verify the official enrollment. Okay? So, I will try to check the submittals that you sent me through the Facebook. Okay? I will check them. I will see, and when I saw those submittals, I will be able to approximate how we are going to continue the subject. Okay? Medyo maingay digdi sa harong, kaya may importante kayang ipatrabaho ang harong, kaya medyo maribok. Okay? That's why hindi ako kabuelo ng maingay talaga. Wala akong ibang mayo akong madumanan na iba kundi digdi sa harong. So, hoping next week tapos na ang ribok din may trabaho. Okay, now, friends, I would like to say, for now, I would like to say thank you for being around, for joining the meeting. I hope you na nabuksan na yung subject natin, patuloy, diretso na. Actually, you can check the content of the subject by checking in the website of the CHED, where the prescription of the course for mechanical engineers is very much understood. It's well presented. Yung CHED memo number series of 2017, I think. Anyway, I'm going to give this to you next in the syllabus. But for your advanced study, do not hesitate to look, to search the web, to search the internet. In the web, there are a lot of information that you can get that will help you do well with your course. Again, let me say thank you all for coming. Now, I can excuse you all for your next schedule, for your next topic.